Hello, I am Mrs. B. Shanti Chalaya, going to discuss multivibrators, sawtooth generator, square wave generator using op-amp in this lecture. The waveform generators are classified as multivibrators, sawtooth generators, and triangular wave generator. Multivibrator is of two types, a stable and monostable multivibrator, which is used to generate square wave. Sawtooth and triangular wave generator generates triangular wave and sawtooth wave using op-amp. Now we will discuss the principle of operation of multivibrators. Multivibrator using an op-amp is a regenerative circuit that generates continuous or pulsed square wave form. There are three main types of multivibrators: a stable multivibrator, which is a free running square wave, and monostable, which is one stable state generating a single pulse, and it is also called as one short circuit, and another one bistable multivibrator, which has two stable states acting as flip-flop. These circuits use passive components, resistors and capacitors, and positive feedback to generate or store digital waveform and timing pulses. The principle of a stable multivibrator continuously switches between two states without any external triggering. It has no stable state. The circuit diagram is shown as in this slide. It consists of an op-amp with a positive feedback, and in the negative feedback you have the passive component RF and C, which determines the frequency of oscillation of the output of the square wave. The capacitor charges and discharges between the upper and lower threshold voltages of the Schmitt trigger. Every time these thresholds are reached, the output swings between the positive and negative saturation voltages Vsat plus Vsat and minus Vsat. The circuit utilizes positive feedback through a voltage divider network R1 and R2 to create hysteresis. It provides negative feedback through an RC timing path to control the oscillation timing. The frequency of oscillation F is determined by the resistor and the capacitor. F is equal to 1 by 2 RC ln of 1 plus 2 R1 by R2. As shown in the waveform, the capacitor discharges between plus Vsat to minus Vsat between the threshold voltages VUT and VLT. We will discuss the principle of operation of next multivibrator, monostable multivibrator. It has one stable state and one quasi-stable state. It is low cost. It produces a single pulse when trigger pulse is given. It has one stable state. When an external trigger pulse is applied to a predetermined time period, the output flips to an unstable state for a predetermined period before automatically reverting back to its stable state, thus producing a one pulse. It is used in design of timers and pulse stretching circuits. The circuit diagram is shown as in the slide, and it is designed using op-amp. A trigger pulse is given using a filter and a diode along with an capacitor. The positive feedback is given through the voltage divider network R1 and R2. The timing component R and C determines the time period of oscillation for the monostable multivibrator. Now we will discuss the working of monostable multivibrator. When an external trigger pulse is applied, it switches to a temporary quasi-stable state for a predetermined duration of time period T. The positive feedback network comprises of the Schmitt trigger configuration connecting from output to the non-inverting terminal through a voltage divider network. The clamping diode in parallel with the capacitor is used to lock the voltage in the stable state. The triggering network provides negative pulse to the non-inverting terminal. The capacitor discharges from 0.7 volt and charges towards minus Vsat. Once the capacitor voltage drops below the reference threshold voltage, the reference threshold set by the feedback resistors, the op-amp rapidly flips back to the plus Vsat. The width of the generated output pulse T is determined by the resistors and capacitor values according to time period T is equal to RC into ln of 1 plus R1 by R2. If the feedback resistors are equal, R1 equal to R2, capital T is equal to 0.693 R into C. The component which is used in the design of the circuit is the active component is the op-amp, timing components are R and C, which determines the width of the output pulse, and the feedback resistance R1 and R2, which sets the threshold voltage for the op-amp. The diode clamps the capacitor voltage to prevent it from going positive during the stable state. The simple RC high-pass filter acts as the differentiator to convert the step input into a sharp negative spike, which is given as the trigger pulse to the monostable multivibrator. Now we will discuss the principle of sawtooth generator. The sawtooth generator has a linear charging interval and a rapid discharge interval to provide a sawtooth wave. It has the frequency of oscillation is controlled by the RC component. The sawtooth generator is an electronic circuit that produces a linear non-sinusoidal circuit waveform with unequal rise and fall times. It features a slow linear ramp and steep drop. It is commonly used in oscilloscope, synthesizers, and pulse width modulation. It is designed using two op-amp 741 as shown in the diagram. The ramp is a constant current source or resistor slowly charges the capacitor, creating a linear increase in the voltage. Once the voltage hits the specific threshold, a switch activates and quickly discharges the capacitor to reset the cycle. The op-amp 1 schematic trigger will act as a comparator, setting the upper and lower threshold limits. The op-amp 2 acts as the integrator, integrates the square wave from the schematic trigger to produce the linear ramp. By using diodes and different resistors for the charge and discharge path, the circuit creates an asymmetrical rise and fall time, resulting the perfect sawtooth. The key applications of the sawtooth generators are time-based generators, music synthesizers, switching and modulation. Next we will discuss the principle of working of triangular wave generator. The triangular wave generator is designed using schematic trigger and integrator. The schematic trigger generates a square wave and the square wave is given to the integrator which produces the triangular wave. It produces a symmetrical continuous triangular waveform. The frequency is given as f is equal to R1 by 4 R2 R3 into C. It produces a periodic non-sinusoidal waveform with linear rise and fall time. It is typically built using two op-amps. The first acts as a comparator, square wave generator, and the second acts as the integrator, converting square wave into triangular wave. The first op-amp switches between positive and negative saturation limits, outputting a square wave. The second op-amp produces a triangular wave, which is the integrator circuit, and op-amp with an input resistor and a feedback capacitor. As the capacitor charges and discharges with constant current, it produces linear alternating voltage ramps generating a triangular output. The characteristic of the wave is given as below. Frequency f is equal to R1 by 4 R2 R3 into C. The peak to peak amplitude of the triangular wave VPP is given as 2 into R2 by R1 into Vsat. The common applications of triangular wave generator are testing and calibration equipment, audio synthesis and signal generation, and in pulse width modulation and thyristor firing circuits. Thus, we have discussed the various types of waveform generators using op-amp. They are essential electronic testing tools that synthesize precise signals for circuit design, troubleshooting, and device characteristics. They range from basic analog circuit topologies to advanced, highly flexible instruments. Most functional versatility and control is available using op-amp. It allows engineers to precisely control signal frequency, amplitude, phase shift, and DC offset. It is limited to arbitrary waveform generators which uses digital memory and digital to analog converter to reproduce extremely complex non-repetitive real-world signals. Thank you.